Welcome, Junior Techies. My name is Mrs. Ramla. This video is on the section skills, and in this video we are going to do more practice on drawing graphs. Right, let's get down to practicing our graph skills. Now, let's look at the first graph. The instruction says draw two graphs on the same set of axes. Same set of axes, so you're going to draw two graphs. That means that's one axis. So you'll have two graphs on the same set of axes. What is it going to show? Changes in heart rate of two boys, John and Tabo, as they run over a certain distance. Right, so that is now the instruction. Two graphs, one set of axes, same set of axes. Now, before we even start drawing the graph, we know we first have to find out what is the dependent variable here. Now, the dependent variable is what you're measuring. Now, I'm sure most of you immediately going to say distance. No, I always start off with my independent first and then my dependent because it makes it easy. Independent with an I control it. You see, I control distance. I chose to do the distance, make the boys run over 1,500 meters. I could have chosen 3,000 meters, 100 meters. That's why it's called the independent variable. And of course, what are you measuring? The heart rate. Because let's be honest, you cannot actually control someone's heart rate. Okay, so now that we figured out, let's look at how the graph should be. So there's your axis. Immediately when you draw your line, your y and your x-axis, you must put the 0 at the origin. Make sure your scale points are very, very clear on both axes. Then, the number that you start off with, that's the number that you go up in. So here, on the dependent variable, there it is, heart rate, beats per minute. I just want to close my bracket, beats per minute. And then x-axis, distance, meters. Always have answer and unit. Always heading and unit, please. And then make sure again, I start off with 100, so I go up in multiples of 100, here 20, and I go up in multiples of 20. And then you plot your graph. Your plotting points must be clear. And then this is a jagged line graph, so you use a ruler to draw the graph. Now, I know most of you would have taken different color to draw them. That wastes time. Here, the best way, just use a key. Label the line graphs A, B, and tell me what A and B stands for. And then don't forget your heading. Line graph showing what? Not the heart rate. As these boys are running, their heart rate is changing. So it shows the changes in the heart rate of two boys, as they run over a certain distance. So you must have the two variables in your heading. Right. There's a question based on the graph. So what is the relationship between exercise and heart rate? So let's go back. So exercise. As the boys are running further and further, what's happening to their heart rate? You can see their heart rate is increasing. So the further the distance run, the faster the heart rate. Or you could have said, as the distance increases, so too does the heart rate increase. Right. That was the first jagged line graph. Let's look at the another one. Translate the information in the table into a line graph on, again, the same set of axes. It gives the percentage of male and female cigarette smokers age 16 and over from 1972 until 1982. Right. Now here, again, what am I controlling? Independent variable, I'm controlling the time. You see, I did the experiment from 1972 to 1982. I could have done it from 1990 to 2000. And then, of course, it makes it easy. Dependent variable, what are you measuring? The percentage of cigarette smokers, age 16 and over. Right, let's see what the graph looks like. There's your axis, there's your 0 at the origin. Scale points are very clear. Now, you cannot start your graph from 0. You'll be here forever to draw your graph. You might not even finish your graph in your lifetime. So, we just start off from 1972 and you go up in multiples of 2, 72, 74, and 76. I know that's quite different from everything else that we've taught you, but that's for years. So, heading, time and years, that's your x-axis. What are you measuring? Your dependent variable, percentage of cigarette smokers, and your unit is there. Then, you plot your points. Again, your key, A and B. You don't have to use different colors. A is males, B is females. Use a ruler to join your 13 points. Then, what's your heading? a line graph of the percentage of male and female smokers from 1972 to 1982 or in 10 years. Right. That should be easy. Right. What trend can you infer about the two graphs? That means, what can you tell me about the smoking in general? So, can you see in general, smoking is decreasing? Right. So I can see it's decreased. But when you're talking about trends, make sure you always have the years, right? So from 1972 to 1982. That's the next one. Are you comparing smoking in males to smoking in females? Let's look. So females, there's a greater decrease in female smoking than males. So females smoke less than males from 1972 to 1982. Always make sure you have both your variables in your answer. Right. Next graph. Translate the information in the table below, showing the number of learners in a class of 35 who like different types of sports, and you translating this information into a bar graph. So again, independent variable. I control it. What am I controlling? The types of sports. Yes, I chose only these types of sports. I could have chosen any other type of sport. Dependent variable, what you're measuring, the number of learners who like the sport. Right, let's see what your graph should look like. There's your axis, there's your 0, your multiples, 2, 4, 6, 8, 10, and then number of learners, that's what you're measuring, your unit is there. And then you always make sure you have a space, bar, space. The spaces between the bars must be the same, and the bars must be the same width as well. Again, don't use color, no coloring in, you use a key. Then you tell me here what S stands for, which is soccer. What R stands for. You can use letters, you can use names, anything. Numbers, whatever. You can even spell out your name, it's fine. Right, let's see what the questions are here. So which sport is like the least? We can see it's volleyball. And then we can see which sport is like the most in netball. Right. Easy. Right, translate the following information into showing the rainfall in millimeters per month for Tswane in 2004 into a histogram. Now, a histogram is different from a bar graph because it has no spaces. So, there we go again. Independent variable. What are you controlling? Yes, you're controlling the time. You did this experiment in a year. You could have done it over 2 months, 6 months, 24 months. And then what are you measuring? Rainfall. Right. So this is what your histogram will look like. There's your 0 at the origin. There's your 50, 100. Your scale points are clear. Your multiples, they go up, multiples of 50. Then there's no spaces between the bars. And then you have your unit, amount of rainfall. Not just rainfall, what you're measuring. You can't just measure rainfall. The amount of rainfall, unit, millimeters, and then, not month, that's a unit. The heading is time. That's an easy trick. And then no spaces between the bars, and the bars must be the same width. And then I use JFMA, that's my key. And then I just put it next to my table because I didn't have any other space. But you can write key, you can write J for January. You can use number 1, 2, 3, 4. You can even spell out your name. Okay, and that's how you draw a histogram. Try not to use color, it really wastes time in your exams. Alright, thank you for watching this video on graphs. I hope you learned a lot, practice a lot of graphs, master your skills so you can do well in your exams. So thank you for joining me. Join me and watch all my other videos as well.